In exercise 4 on lesson 4, we're looking at expanded form using exponential notation. Now, expanded form, just a reminder, is where in elementary school you would write things out in their hundreds, tens, thousands, ones, etc., using that place value. Now, the key behind using exponential notation there in expanded form is that, we can use powers of 10. That like 10 to the first is equal to 10, and 10 squared is equal to 100. So we're keeping that in mind as we go through here. So 8,000, let me just erase this line here, and we look at 8,000 being the same as 8 times 1,000, which is 10 to the third, plus 3 times 100, which is 10 squared, plus 70, and 70 is 7 times 10, which is 10 to the first, and then I need to give myself a little room here, and we have plus 4, and 4 is the same as 4 times 1, which is 4 times 10 to the 0 power. There's that 0 power being equal to 1. Now we're doing the same thing in expanded form using exponential notation for exercise 5. So we just have to think of the place values, like how many zeros would be behind each one, and that's the power of 10 that we're using. So the expanded form here, we would have the first digit, as we've got 6, and that's times 10, and we look at how many zeros are behind it, and that's 6 zeros, so times 10 to the 6th, plus we've got 9, and that's 9 times 10 to the 5th, 5 zeros behind that, plus 8 times 10 to the 4th. So you see how we're just moving down a power of 10 based on how many zeros are behind that number, plus 5 times 10 to the 3rd. And then we have that 0 there. We don't need to include that because, of course, that's just a placeholder. But then when we get to our plus 6 times 10, we've got to be careful. We're not just moving down one spot here, we're moving down 2. And so that's 10 to the first power plus 2 times 10 to the 0. Again, that ones place 10 to the 0 because anything to the 0 power is 1. All right, so looking at our problem solving set, we're just kind of practicing our rules with that 0 exponent. So you see number 1, we have y to the 12th divided by y to the 12th, and you know your rule for dividing exponents with the same base is that you can subtract those exponents and you get y to the 0, which now you know is just equal to 1. For the next example, we are multiplying here. When your fraction does not have a denominator, you should know that your denominator is 1. So we end up with 9 to the 15th over 9 to the 15th. Very much like example 1, that's 9 to the 15th minus 15. So we end up with 9 to the 0 power, which is equal to 1. For example number 3, we have, several pieces multiplying here. This one looks really complicated, but when you're raising a power to a power, you multiply. So that's just really going to be everything inside, and I'm not even going to bother to write it. I'm just going to show you it's going to be everything inside those parentheses to the 4 times 0 power, which of course means it's everything in those parentheses to the 0 power, which is equal to 1. So when you see that it's going to be to the 0 power, it's nice to just know that that is equal to 1. For number 4, we've got several steps here. Again, remember that when you don't have a denominator, you have a denominator of 1. And when we're multiplying fractions, we're just multiplying across the top. So we end up with 2 squared over 2 to the 5th times 2 to the 5th over 2 squared. And you can go through those steps. That's, when we have the same thing in the numerator and denominator, they can kind of cancel because that's just equal to 1 times 1, and that is equal to 1. And then we have example 5. So we have x to the 41st times y to the 15th all over y to the 15th times x to the 41st. So we have that same idea of something in the numerator canceling with something in the denominator, because if we would subtract those exponents, we would just get 0. 15 minus 15 would also be 0. And so we kind of get x to the 0 over y to the 0, which is really just 1 over 1, or 1 whole. So the key idea here is anything to the 0 power is 1.